Hi, class. This week in our lecture and our topics that we'll study is we're going to take the concepts of hypothesis testing and confidence intervals and expand it from having one sample to two samples. So basically what we're doing is we're going to compare the parameters of two samples, right? So I have four problems from your homework picked out, and what I want to do is I want to show you how you can easily use StatCrunch to solve this. All right, so the first one I'm going to do is problem number 3 from your homework. So it says conduct a test at the alpha is equal to 0.10 level of significance. All right, so part A says determine the null and alternative hypothesis. So right here we want to test whether proportion 1 is greater than proportion 2. Well, your null hypothesis is always a statement of equality, so it's always P1 is equal to P2. And what we're doing in our alternative is we're looking for evidence to say that, oh, wait a second, no, proportion 1 is greater than proportion 2. All right, so remember when you go to do this, that the null H0 is always a statement of equality. All right, the next thing says is determine the test statistic. All right, and what it has here is it has all your sample data right here. So we'll want to use StatCrunch very easily for this. So let's go load up our StatCrunch, as we have been doing. All right, and if you look here, they give you the sample data. So whenever you have a P, all right, like P1 is greater than P2, you're going to go stat. It's going to be a proportion stat. And here it's two sample and with the summary of data. So sample 1, it looked like X1 was 129 and the number of observations was 247. So let's plug that in. X2 here, the sample 2, looked like the number of successes was 133, and the sample size of the number of observations was 308. So we plugged those in, and we wanted to do a hypothesis test, and we wanted to test to see, all right, that their difference is greater than 0. So what happens is like they have it over here as P1 is greater than P2, but if you subtract P2 over, you get P1 minus P2 is basically greater than 0. That's what they wanted to see. So I'm going to hit compute. And here it says this z-stat is your test statistic, and here's your p-value. So it said find the test statistic to 2 decimal places. So I'm going to take 2.12, plug it in here. Excellent, I got it. And now let's see, determine the p-value. And this says to go to 3 decimal places. Well, they have it right here at 0.017. And we got it just like that. So what is the result of your test? Well, if you look here, our p-value is less than our level of significance. So we're going to reject the null. This is because there is sufficient evidence to conclude this, right? So it's going to be D, and we got it just like that. So notice how this problem, it might take a while to like figure out what the correct result is, but as you can see, like StatCrunch does this very quickly for you, like the test statistic and the p-value. All right, let's go look at question 4. Right. So this says not a hypothesis test, but a confidence interval question. So it says construct a confidence interval for the difference P1 minus P2 at the given level of confidence. Right. So I have number of successes and observations for the first sample, number of successes, observation for the second sample, and I want 99% confidence. So again, I'm just going to StatCrunch this. Whenever you're dealing with these proportions, like P1 minus P2, you're going to go stat, proportion stat, to sample, and with summary. So it was 352 for the first one, 512 was the number of observations, then it was 425, and 585. So we want a confidence interval here for the difference, and I want to change this to 99%, so just be mindful of that. And I'm going to hit compute. Here's the lower limit, here's the upper limit of it. So it says round to 3 decimal places. Right, so this is going to be negative 0.114 when I round it. Researchers are 99% confident the difference between the two population proportions is negative 0.114. And then to 3 decimal places here, I'm going to have to round that last digit to an 8. So it's going to be 0.028. Like this. And we got it. So as you can see, anything that involves these calculation problems, just StatCrunch. Very quickly done in StatCrunch. All right, we've done 2 problems with proportions. Let me skip ahead and do some problems related to a mean. So I'm going to skip ahead to number 7. Okay. So the following data represents the muzzle velocity in feet per second of rounds fired from a 155 millimeter gun. All right, for each round, 2 measurements of the velocity were recorded using 2 measuring devices, resulting in the following data. So what happens is 1 shot gets 2 measurements. Okay, that's what we're saying. 1 shot is measured twice. All right, and we have the data here. All right, so it has the observation and then what the measurement will say. Whenever you see this double pane here, okay, that's going to allow me to take this data and plug it into StatCrunch. All right, but first, why are these matched pair data? Well, as I said, all the measurements came from rounds fired at the same gun. All right, so the other thing here, the 2 measurements, A and B, all right, which are matched, are taken from the same round. All right, so because A and B are matched, are taken from the same round, taken from the same round, taken from the same round, this is why that these are matched pairs. Okay, so is there a difference in the measurement of muzzle velocity, all right, between device A and device B at the 0.01 levels of significance? All right, so we're just telling you that they're approximately normally distributed with no outliers. That just means because we have a small sample size, we're allowed to use the methods we've been talking. So I want to see if there is a difference. So the first thing I'm going to do is I'm going to assume that there is no difference. And I'm going to test to see that, hey, no way, that difference is not equal to 0. There is some difference that exists. Okay, because there can be a difference because the subtraction is negative or positive. All right, so let's determine the test statistic for this hypothesis test. So again, I'm going to open up this data in StatCrunch. All right, so I have the data here. So I'm going to go stat, tstat, and remember what we said, the data was paired. Okay, so it's paired. So I'm going to click sample 1 is in column or is the data A, sample 2 is in B. And I wanted to perform a hypothesis test that the difference is equal to 0 versus not equal to 0. So I'm going to hit compute. So it says determine the test statistic for the hypothesis, round to 2 decimal places. So here this is going to be negative 1.02 when I round it, which I got, great. What is the p-value? Well, you can load this right back up in StatCrunch. Let's go to 3 decimal places here. So I'm just going to copy it like so. So I actually don't need the StatCrunch anymore. So what is your conclusion? All right. Well, the p-value is a lot greater than any level of significance we would have, right? The 0.01. So we do not reject H0, the null. There is not sufficient evidence to conclude at the 0.01 level of significance there is a difference. So we got it. All right, let's construct a 99% confidence interval now for the population mean. I apologize, we actually do need to go back and load up StatCrunch again. So we're going to open the data in StatCrunch. Again, you're going to go stat, tstat. We want these paired. So again, observation sample 1 is an A, sample 2 is B. So we want the confidence interval for the difference and change it to 99 like that. So when I hit compute here, the lower difference when I round to 2 decimal places is going to be negative 9.84. And the upper bound is going to be 5.87 when I round it. I got it. Great. All right, interpret the confidence interval. All right. So what this is saying here is you got to figure out and read these what this is talking about. So one can be 99% confident that the mean difference in measurement, whatever the mean difference is, we don't know exactly what it is, but we're 99% sure it lies between this interval. That's what we're trying to estimate. All right, so the last part, you can draw the box plot of the difference data. All right, what you can actually do in StatCrunch, when I load this back up, is when I go stat, tstat, paired, you can save the differences here like this. So saving the differences. And you'll notice here that you have a column called differences right here. So if you go graph, what you want is a box plot of the differences like that. And you can see this is what the box plot looks like. So you have to be careful because you'll notice over here, none of them really do a good job looking exactly like it. But you can see you have a tail that shoots off to the negative and a tail like right over the positives like this. So this right here is what the box plot of the differences would look like. All right, so does the visual evidence, all right, support the results obtained in part B? All right, the answer is yes, because 0 is contained in that box plot. Just like that. So as you can see, what happened here is StatCrunch did almost all of this for us. All right, let's just do one last one. So let's switch to problem 10 now. All right, so over here I've got two populations, all right? And here you'll notice X bar, we have a sample mean. So this is going to be a problem related to a mean, right? So use the given statistics to complete parts A and B. So let's assume population is normally distributed. So test whether the average 1 is greater than average 2 at the 0.01 level of significance. Well, remember what I said was you always start, H0 is always a statement of equality. And then we're looking to show evidence for what we want to test. So it's F here. All right. Let's find the test statistic for the hypothesis test. So what I'm going to do is I'm going to load up StatCrunch. And I'm going to go stat, tstat. Now this data is not paired at all. So it's just two sample with data. Or excuse me, stat, tstat, two sample with summary. My apologies, with summary. You're going to click on that. Sample mean for the first one is over here, 45.8. The standard deviation is 5.3. The sample size is 23. The second one, the sample mean is 42.9. Standard deviation is 11.2. And the sample size is 18. And we wanted to test, if you look back here, right, that mu1 is greater than mu2. So I got to switch this to be greater than here. And I'm going to hit compute. So this wants to go to 2 decimal places. This is the test statistic right here. Which I got, great. P-value, wanted to 3 decimal places. It's going to be 0.161 when I round it. So going back, 0.161. I got it. Well, what we can see here is that we wanted to use the 0.01 level of significance. Our p-value is greater. So we do not reject the null. There is not sufficient evidence. Great. So B here, it says, all right, let's just do a little bit different. Let's do a 90% confidence interval. So I'm going to load this back up. And I'm going to go back to stat, tstat, to sample with summary. And I'm just going to re-input those values. As such. Now what I wanted, if you look back here, I want a 90% confidence interval. So I'm going to go confidence interval, change it to 90, and I'm going to hit compute. So here they wanted it to 3 decimal places. The lower limit is negative 2.005. And the upper limit to 3 decimal places is 7.805. And you can see I got it great. And there you go. There were problems 3, 4, 7, and 10 very quickly solved in StatCrunch. I encourage you guys to practice it this week and let me know if you have any questions. All right, good luck.